Thank you very much, Professor Gregory Jones, for the very interesting presentation and indeed a very challenging future for this sector. Now we move to the second presentation of Kees Van Leeuwen, which is Professor of Viticulture of Bordeaux Science Agro, and as well at Bordeaux University Institut des Sciences de la Vigne du Vin. Kees Van Leeuwen conducts research on the concept of terroir in viticulture. His works are centered on environmental constraints in the expression of vine-growing terroir. This constraint is most often a limiting of water supply or a limiting of nitrogen nutrition in the vines. Kees has taken part in the creation and evaluation of several indicators of wine, water, and nitrogen status in vines. He has also worked on the climate's effects on the expression of wine-growing terroir. He has published extensively on the effects of climate change on viticulture. Kees Van Leeuwen is creator and editor-in-chief of the international peer-review open access journal ONO1. So, Kees, please, thank you very much for your participation. It's a great pleasure and great honor to be here and listen to your presentation. Thank you very much indeed.
Yes, thank you, and very happy to be with you. Like Greg Jones, I would have loved to be with you in Porto. I like your region, and I love the wines of Porto. So I'm going to talk more about adaptations. So first we need to know what are the requirements for the production of high quality wines. And of course, to make a good wine, you need balanced fruit. And balanced fruit, that means balance in terms of primary metabolites like sugar, enough, but not too much. And also organic acids, you need to have enough acidity for good freshness in your wine. And also that balance, we need to have it in secondary metabolites, aroma compounds, and phenolic compounds. Now, under warm climates, this balanced fruit composition is achieved when the ripening takes place in cooler conditions at the end of the season. So not in July or August, but when the grapes ripen in September or October, when the conditions are cooler, then we get that perfect balance to produce high quality wines. The growers have always adjusted the timing of ripeness, the moment in the season when the grapes are harvested, by adapting the choice of the grapevine variety to their local climate conditions. So in cool climate, the challenge is to bring the fruit to complete ripeness. So growers have chosen early ripening varieties in cool climates and late ripening varieties in warm climates, where the risk is that the fruit ripens too early in a hot part of the season. And so we can find in a cool area, in a cool region like Burgundy, we find Pinot Noir and Chardonnay, also in the Willamette Valley in Oregon, where the climate is pretty similar to the climate of Burgundy. In Bordeaux, where it's a little bit warmer, people have traditionally planted Merlot and Cabernet Sauvignon, which are not very late ripening varieties, but which ripen a little bit later than Pinot Noir and Chardonnay. And in warm areas like the Douro Valley, growers have selected late ripening varieties like Touriga Nacional and Touriga Franca. And Touriga Franca also has the advantage of not accumulating too much sugar. Now, with climate change, like Greg Jones explained us, a lot of things are going to change. And with increased temperatures, we will have a shifted phenology. I will come back on that point on the next slide. And that means that if the phenology is happening earlier, the cycle of the vine is happening earlier, then the ripening will take place under warmer climatic conditions. We will also face increased drought. And the biggest impact of drought is on the yields. When the vines face drought, then the yields become lower, which of course is a challenge for wine growers. Increased drought not necessarily have a negative impact on red wine quality. We need to remember that you can only produce high quality red wine if the vines during the season meet some amount of moderate water deficit. But water stress can be detrimental, and in particular for white wine quality. Um, Here's a nice set of data from colleagues from Alsace in France who have been monitoring phenology for some 60 or 70 years. And you can see that over this period, bud break shifted by 10 days. Bud break today is earlier by 10 days than it was in the 1960s. Flowering advanced by 23 days, veraison by 39 days. Can you imagine? More than 1 month. And harvest date was advanced by 25 days. Typically in Alsace, harvest took place in the first week or first 10 days of October, and today it takes place in the first half of September. Of course, this dramatically changes also the type of wine which is produced. This is another data set from Languedoc in the southeast of France, from a laboratory, Dubernay laboratory, who compiles data. Each data point is the average of thousands of samples of wine from each vintage. And you can see that the potential alcohol steadily increased from 11.5 to 14.5. The pH increased by 0.2 roughly, and also the total acidity decreased. So it is obvious in this context that wine growers need to adapt. And it is important to separate adaptations to higher temperatures from adaptations to less water, to increase drought. The adaptations are not the same. So let's first focus on adaptations to increased temperatures. And everything that can contribute to delaying ripeness can be considered as an adaptation to increased temperature. The challenge is that we must maintain the ripening window of the grapes in September or early October. And the ripeness should not shift to August, which is definitely not good for the quality because it will lead to unbalanced fruit composition. One way to adapt is to use the clonal variability. Now, to show how big clonal variability inside a given cultivar can be, and I know in Portugal also a lot of work has been conducted regarding clonal variability. Here you can see it is a collection of Cabernet Franc from a wine estate in Saint-Emilion, Chateau Cheval Blanc. And you can see that at ripeness from one clone to the other, there was more than 20 grams per liter difference in sugar, which means more than 1% in potential alcohol. And then we made wine from these different clones, and you can see there was also a big difference in the pH of the final wine which was produced. And there was as much difference as 0.2 in pH, which is quite substantial. So using clones that produce lower sugar levels and lower pH can be a possible adaptation to climate change. But in the long term, this may probably not be enough. And then there is another option, is changing the grapevine variety. And of course, there's much more variability in phenology and composition across cultivars than there is across clones. So we can try to move to later ripening varieties. And for instance, this is the veraison data from a set of cultivars in an experimental field in Bordeaux, which we call the VitaDapt project, adaptation through varietal choices. And we show that, for instance, for veraison, there's as much as 34 days difference if we compare early ripening varieties with late ripening varieties. And so, for instance, in some regions, we can increase the percentage of late ripening varieties in the variety mix. For instance, in Bordeaux, Merlot is an early ripening variety, and Cabernet Sauvignon is a late ripening variety for the Bordeaux climate. So in the future, we should move to a higher percentage of Cabernet Sauvignon and less Merlot. But on the long run, say after 2050, this may not be enough, and we may need to introduce new varieties and then focus on late ripening variety and possibly also varieties with low sugar levels. And in that regard, for instance, Touriga franca is an interesting variety because even at full ripeness, it does not accumulate too much sugar. Training systems can also provide an opportunity for adaptation, and we've done some trials to try to model what can be the impact of increased trunk height on temperatures in the zone of the grapes. So on two blocks, one with where the soil was maintained with tillage, another block where the soil was maintained with cover crop, we put temperature sensors at 30 centimeters, 60 centimeters, 90 centimeters, and 120 centimeters. And what we measured, that was close to the soil at 30 centimeters, the minimum temperatures were lower, but maximum temperatures were much higher. And if you look at a very warm day, 23 July 2019 was an extremely hot day in Bordeaux, we can see that there are substantial differences if we compare the block with tillage and the block with cover crop. Globally, with cover crop, the maximum temperatures were higher, but there was also a significant effect of the height of the sensors. So at 30 centimeters, the temperature was substantially higher compared to 90 centimeters or 120 centimeters. So if you combine the effect of the vineyard floor management and the height from the soil to the temperature sensors, there was about 2.5 degrees centigrade difference between the warmer sensor and the cooler sensor. So that means that playing with vineyard floor management and the height of the trunk, there is definitely room for adaptation. Another possibility is canopy management, and a way to decrease the sugar levels in grapes can be decreasing the leaf area to fruit weight ratio. So this is data from the PhD from Amber Parker, and she showed that when you limit the leaf area to fruit weight ratio, you can delay veraison. The timing of veraison is the horizontal dashed line, but also decrease the sugar accumulation. So with a decreased leaf area to fruit weight ratio, you have a slower sugar accumulation and a lower sugar rate at ripeness. And surprisingly, there was not so much effect on acidity. So the acidity levels were more or less maintained equal. And later on, we did other experiments in Bordeaux, and we have shown that the leaf area to fruit weight ratio has not so much impact on aromas like methoxypyrazines or volatile thiols, but there was a significant decrease in anthocyanins when we reduced the leaf area to fruit weight ratio. So that means that this is more easily applicable to white varieties to make white wine because there's little effect on aroma compounds, but it cannot so easily be applied to red varieties because, of course, to make a red wine, we also need anthocyanins. Another possible adaptation, which can be applied in some regions, but not in every region, is to move to higher altitude. For instance, in Bordeaux, there's very little room for moving to higher altitudes because the vineyards with the highest elevations are around 100 meters in altitude. But in a region like the Douro Valley, there are substantial temperature differences with variation in altitude. And this was shown by Greg Jones and Fernando Alves in a study they published in 2012, where they showed that the highest temperatures are close to the Douro River. And if you move up in the mountains, then the average temperature decreases. Growers will also need to adapt to increased water deficit, and those adaptations are different in nature than adaptations to higher temperatures. But we can focus very much also on plant material, and the rootstock is a major tool to adapt to a drier climate. Some rootstocks are very, very drought resistant, and among those, 110R or 140 Ruggieri are very much drought resistant. And we should use these drought resistant rootstocks in dry environments. I like very much this picture, which was taken by my colleague Hans Schultz in Australia, in a very dry environment, in a vineyard block that was planted for half with 110 Richter and for half with SO4. And it's very easy to see that 110R resisted to those dry conditions, but SO4 did not. And there's also ongoing research in several research stations around the world where people are looking for more drought-resistant rootstocks for drier environments. We also need to take into consideration that there are big differences in how grapevine varieties behave under drought. The Mediterranean varieties and also many varieties from the Iberian Peninsula are drought resistant because they were selected by growers in a dry environment. And we should absolutely avoid using varieties which are sensitive to drought in dry climates. And once again, some pictures to show how big the differences are in drought resistant when we compare variety. This is Grenache, cultivated in Aragon, one of the driest regions in Spain, where grapes are cultivated with only 350 millimeter of rain a year without irrigation. And the vines behave perfectly well. And these vines produce 6 tons of grapes per hectare. Now, these people tried to use other varieties which are not drought resistant, like Merlot or Tempranillo, Tinto Roriz, or Sauvignon Blanc, and they simply do not resist to so much drought. So it's in dry environments, it's important to stick to varieties which are naturally resistant to drought. Training systems can also be a good adaptations. And once again, in the Mediterranean area and in the Iberian Peninsula, we can find training systems which are very well adapted to dry environments. And like the Goblet pruned bush vines, they are typical for the Mediterranean environment. And it's a pity that a lot of people are pulling out these varieties. It's a strange situation. We are moving to more and more drought. People have, over the last thousands of years, figured out a training system which is particularly resistant to a dry environment. And now we are pulling these vines out in a context where we're moving to more and more drought. We should absolutely preserve these vines. But if we want to use vines which are planted in rows, because maybe they are more easily harvested by machine, we can play with the row spacing. And the effect of the row spacing on the water availability for the vine can be easily modeled. Here's some results of this modeling where we compared the fraction of available water during the ripening period for vines which were spaced 2 meters, 3 meters, or 4 meters. And what we see is if we move from 2 meter spaced vines to 4 meter spaced vines, the availability of water increases. And so that means that with less vines per hectare, a wider row spacing, during the grape ripening period, there's more water left for the grapes. And this is, of course, in unirrigated vineyards. Now, of course, it's also possible to irrigate. And if people think about adaptation to increased drought, the first thing that comes to mind is generally irrigation. And of course, it's possible with irrigation in dry environments to produce higher yields. But we need to be very much aware that there are millions of hectares in the Mediterranean basin and in the Iberian Peninsula. And historically, these vines were not irrigated. And there will be never enough water available for all these vines if we start to irrigate them all. So in some situations, irrigation can be a solution, but it cannot be the solution everywhere, because just we are running out of water. We need to be very much aware that irrigation is not an environmentally sustainable solution because water resources are declining. And there's also another issue with irrigation, is that it can induce salinity problems. So it is very important to be very much aware that all that know-how, all the knowledge that exists in the Mediterranean basin and in the Iberian Peninsula about dry farming, how to dry farm grapes, is a very, very precious skill. And we must maintain it as much as possible in the Mediterranean basin and the Iberian Peninsula. So, as a conclusion, it's obvious that in grape growing, temperature and water are major climatic parameters, and that now these parameters are changing, we need to adapt. So, the effect of increased temperatures is that the phenology is advancing and that we have higher temperatures during grape ripening, which is not good for the balance of the fruit and the quality of the wine. And as a general rule, every adaptation that can delay the maturity and maintain the ripeness of the grapes in September or early October is a good adaptation to increased temperatures. And plant material is the most promising option to achieve this goal. The major impact of increased drought is not so much the impact on quality, but the impact on yield. With increased drought, the yields are declining. And once again, plant material is a very good option for adaptation and also training system. And if we adapt to drought by playing with the plant material, the rootstock, the grapevine varieties, and with the training system, those adaptations are sustainable. Irrigation is also, of course, an adaptation, easy to implement, but not always sustainable because the water resources are declining. Thank you very much for your attention.